So this goes right back to what we talked about with contamination. The dirtier the oil, the shorter the engine life is. So when you think about the Hemi tick and roller camshaft failures and these bearing issues that are been plaguing OEMs, let's face it, modern engines just aren't built the same anymore. Hi, I'm Lake, the Motor Oil Geek, and there is something common about all of these modern mechanical problems that relates to motor oil. OEM recommended viscosity and oil change intervals are part of the problem, but probably not for the reason that you think. If your engine has variable valve timing, displacement on demand, or a turbocharger, this video's for you. And just as a reminder, motor oil does more than just lubricate the engine. It provides protection against rust and corrosion. It helps clean and cool and seal the engine. We've mentioned this in previous videos, but there's one other really important property that motor oil provides for modern engines: hydraulic force. That's right, modern engines use motor oil as hydraulic fluid. And this is where the problem lies. This is the Lubrication Engineer's Manual. Many people consider it the Bible of lubrication. Oddly enough, it is not published by the Society of Automotive Engineers. It actually comes from the Association of Iron and Steel Engineers. That's right. When it comes to lubrication excellence, you have to go to the industrial world. Unfortunately, automotive lubrication doesn't normally have the very best reputation in terms of being excellent. When it comes to aerospace or industrial applications, think nuclear power plants, this is where lubrication excellence is required on a daily basis. It's a 24/7, 365 requirement in many applications. So when you want to get to the facts, this is where you have to go. And there's a whole chapter in here just on hydraulics. And the reason this is important is because variable valve timing and displacement on demand systems are using the motor oil as hydraulic fluid to operate these systems. So the principles of hydraulic fluid performance and maintenance are critical to making sure your modern engine with these systems works properly. And when it comes to hydraulics, cleanliness is next to godliness. Now, there are several studies, and I'll share one right here just from Chevron, but other companies such as Timken and Noria, they have studies that have positively shown a correlation between the level of contamination in a hydraulic system related to hydraulic system life. Simply put, the dirtier the fluid, the shorter the engine life is. And we can see that in these results right here. The number one source of equipment failure is contamination. 82% of mechanical wear is down to particulate contamination. In previous videos, we've talked about the particle count and how important it is. High levels of particle count means a higher level of contamination in the system. So it's critical in these modern engines using oil as hydraulic fluid to make sure that fluid is clean. Because cleanliness is so important, it's yet another reason not to use aftermarket additives, especially if they contain nanoparticles or any other kind of solid lubricant. Because high levels of particulate contamination lead to abrasion, erosion, and fatigue. And these particles causing damage in your engine, you can't see with your naked eye. We're talking about particles smaller than 40 microns. Many times, these particles are smaller than 20 microns. And as we know from our previous videos on filtration, clearance-sized particles do the most damage. And the clearance is inside variable valve timing systems and displacement on demand systems. Hydraulic roller lifters, they are less than 20 microns. Particles your filter may not catch can cause damage. And just to be clear, I am saying that oil cleanliness is more important than oil brand. Since it's quite obvious that cleanliness is incredibly important, maybe we should make a trip back to go visit the folks at Donaldson for maybe a deeper dive on filtration. If you want to know, let me know in the comments below and we can organize that trip. Dirt, sand, and water are typical contaminants that we see cause damage to engines. Essentially, when those numbers are high in the used oil sample, we see a higher level of wear in the engine. And this correlates exactly to what's seen in industrial and aerospace applications. Essentially, when the ISO cleanliness code, which is a rating for cleanliness, the higher the number, the dirtier the oil, when that code goes up, equipment life goes down. It's really that simple. So just to put some numbers on it, if the ISO cleanliness rating of the oil is greater than 17, 15, 13, it's going to lead to shorter equipment life. We typically see engine oils dirtier than that. And this is where the OEM advice is causing problems. So at Joe Gibbs Racing, we had a pretty interesting experience with our needle bearing roller lifters. Our manufacturer of those needle bearing roller lifters said, "Hey, what are you guys doing?" We're very curious as what did we do wrong? And they're like, "No, you didn't do anything wrong. Why are your lifters living twice as long as all of your competitors?" And we had to do some digging and understanding, ask those guys a bunch of questions, and what we came to realize was that at Joe Gibbs Racing, we used the same dyno and the same procedure to break in both the flat tappet engines and the roller cam engines. So we were doing a cam break-in on a roller cam, even though you didn't really need it. And the key thing here is this. It wasn't that we did a 30-minute cam break-in necessarily that made the lifters live longer. It's the fact that we used the break-in oil that was designed to break in the flat tappet cams. And of course, what did you do immediately after doing the cam break-in? You changed the oil. So before that engine, that roller cam, ever saw the racetrack, the oil had been changed 3 times. Because Speed Diagnostics has taken used oil samples from vehicles with as little as a couple hundred miles on them, all the way to several 100,000 miles on them, we have a pretty unique data set that gives us an insight to engine wear versus engine mileage. Now, we've covered this in previous videos. The most amount of normal wear that will ever occur in an engine is during engine break-in. For all you flat earthers out there that don't believe in engine break-in, that think engines are broken in from the factory, I hate to break your heart, but here's the data that proves you wrong. We see higher levels of wear during engine break-in, which can take up to 10,000 miles to happen. We see over 60 parts per million silicon in the oil compared to maybe only 12 parts per million average after break-in. And that's just one element of contamination. When you total together all the contaminants, all the wear metals, it's typically 3 times more wear during early break-in than after break-in. And this is the key thing. All of that wear is circulating through the engine. We've already talked about it. Your oil filter is not capturing all of that debris, all of that contamination. So during that break-in period is when you should be changing the oil the most often. The factory recommendation of 5,000 or 10,000 or 15,000 miles on the first oil change is absolutely ridiculous and this data proves it. You need to be changing the oil much more often early in the engine's life. But before all my 3,000 miles or every 6 months people chime in, hang on. Because once we see that the engine is broken in and it's normalized, you can go further on your oil changes and back to the fact the filters get better as they get more usage. It's better to not change your oil filter every 6 months or 3,000 miles because you're resetting the performance of the filter to a lower level. The oil will be dirtier that way. We've seen that in previous videos, that the brand new oil out of the bottle will have a higher ISO code, dirtier, than after it's been running the engine for a while. If you go back to our previous video, you can see that. The ISO codes on the 0-hour samples were higher than after 2 hours. Why? Because the more it ran, the better the filter did. It cleaned the oil up. So oil change intervals really need to be based on engine life. Shorter initially during the engine's life, longer during the middle part of the engine's life, but then toward the end of engine life, what the data shows us is that wear becomes more unstable. And all of this really comes down to surface texture. We've mentioned this before in a previous video. Surface texture is critical to engine health and performance. Early in engine's life, they're going to be rougher and they're going to break in, which we just talked about. And that break-in debris goes throughout the engine. It can cause damage in your engine. So you got to get that break-in debris out. But once that surface is broken in, and we have the right level of smoothness on top to hold the load, valleys to hold oil, we have good lubrication, good long life. But as that wear occurs over time and we begin to lose that, now it becomes too smooth and now wear begins to increase again. This is just the life of a surface. So potholes and roller camshaft failures actually have something in common. Both begin below surface. Similar to how when water freezes below the surface of the road, it causes a dislocation that propagates and leads to the pothole. Roller camshaft failure begins subsurface with a dislocation. Just like my really good friend and brilliant engineer, Billy Godbold, always says, every macro failure actually begins at a micro level, and it begins when applied force exceeds material strength. So what happens here is that you have those microparticles that are very hard. When those particles get between the two surfaces, now all of the load gets concentrated in that smaller area. So when those forces go up, it can exceed the material strength that causes that dislocation subsurface. Over time, that small dislocation propagates and leads to those big macro pits. So roller camshaft failure and potholes actually have a lot in common. That's the part of oil drain intervals being wrong. What part does viscosity play in this? And a great real world example of this comes from 0W20 oils. In gasoline engines where there's not a lot of soot and not a lot of contamination, but that's not the case in a diesel engine using a 0W20 in, say, comparison to a 5W30 or 0W40. We see a lot less wear in those diesel engines with the thicker viscosity oils. Why? Because there's more contamination, there's more soot in the oil. So this goes right back to what we talked about with contamination. The dirtier the oil, the shorter the engine life is. So when you think about the Hemi tick and roller camshaft failures and these bearing issues that are been plaguing OEMs, well, it points right back to this, cleanliness. If that oil did have machining debris left in it from the manufacturing process, guess what? It only sped up the imminent demise of that engine. And that should be the big takeaway from this video. Increased contamination leads to increased abrasion, erosion, and fatigue, which leads to shorter engine life. So what can you, the viewer, do about it? Well, number one, we already showed. Change your oil more frequently early in the engine's life to get rid of all of the debris that's being created during break-in. Once you get past the break-in period, you can extend those oil change intervals back out further. Then toward the end of engine life, you need to shorten those oil change intervals yet again. And it's also a good idea to make sure you're using top-tier gasoline to keep those injectors clean. Because when injectors get dirty, you get higher fuel dilution. And higher fuel dilution lowers viscosity, which just further compounds all of these issues. Also, make sure you're using high-efficiency air filters and oil filters. Don't fall for the high-flow trick of the week filters. Use the products that provide the highest level of efficiency at the smallest micron rating. And if you're trying to go for those extended oil change intervals, you know what? That centrifugal bypass filter may not be a very bad idea after all. Hope you enjoyed this video. Thank you so much for watching. Until next time, check out one of these and we'll see you next time.